In this video, we're going to go through the homework problem, the first one we did. You want to make sure that you save your file in the correct directory. That's the CSC2180 directory. And the first file should be called swap value, I think. Make sure I've got that right. You have everything until you need it. I think it'll be on my screen in a minute. I think it's called swap. Oh, it's just called swap.cpp. Okay. And the second one is called positive negative capital N.cpp. Again, it's important that you name it exactly like I've got it. So when I go to grade it, I can find it. Okay. So I'm going to switch over I'm using Warp, but terminal should work more or less the same way. Okay. So now that we're over here, there we go. Now we're in the share. Okay. I can go ahead and connect into the server. Okay. And I probably need somewhere to have the exercises. Just handy. Right. And the first one is called swap.cpp. Okay. So first thing I have to do is I have to be able to log on to the computer. Okay. So to do that, I'm going to do my SSH. You see that it's already highlighted for me. If I just hit the right arrow key, I could be done. But I'm going to go ahead and do it slow this time. It's DEF3. Wait, you don't need me looking at you. Can I get rid of that? I think. Not gonna there we go. That helps. DEF3QU happens to be my username. Put in your username at ludwig.mcs.uvays.edu. Okay. Then I'm typing my password. Okay. And then I can ignore all that. It's not been clear if you don't want to look at it. A PWD tells me I'm in my home directory. I can do a CD CSC 2180. And now PWD returns the correct value. Okay. So I can go ahead and do an Emacs on swap.cpp. Okay. And what I've done here, I've just copied over. This is everything that was in the screen. So for me, I used the mouse to highlight, right click it, say copy. I then moved over I opened up Emacs and then I clicked on the open window with Emacs in it and did a right click and paste, or Control V should also work. Okay. So when you're given the starter code here, it's best to start with that. So let's see what's happening here. So we're declaring two integers, X and Y. We're asking the user to enter two integers. We're doing the CN. When you link them up this way, okay, it's going to mean that it's going to just allow you to put a space between them. Okay, that's all. Okay. Then we're going to have a C out here, which is going to print out on the screen the value of X before the swap, and then the value of Y before the swap. Okay. We're then going to swap values on ampersand X and ampersand Y. Okay, so that's going to be the address of X and the address of Y. Okay, so this is the memory address where they're stored at. We do this so we don't have to worry about returning anything. Okay, we can just change the values of X and Y in the function, and we're going to be fine. Okay, so these memory addresses, and then we're going to print the same thing out again. Same as the line up here, but it's after the swap. Okay. So this ampersand X, we can't send it to the function as an int. It's got to be an int star since that's a memory address. Okay. So up here in our swap values function, which they gave us, it's a void function. Again, we don't return anything because we're sending along by reference, the changes we make are permanent back in main. Okay. So swap value, int star A, int star B. It could be X, Y, it could be whatever you want. Okay. But in this case, because of the order that we sent them in, okay, and we could note this if you like, just make a note to ourselves here, not there, make a comment here that A points to the memory, I cannot type, say my life sometimes, to the memory location of X, and therefore B points to memory location of y, okay? Which can be a little bit helpful to us, okay? So the point is we want to write code to swap these values that are pointed to by A and B, okay? So to do this, if we just want to swap one to the other, okay, to get to X, so in this sense, we can say the value of X then is going to be equal to dereferencing A, okay? And in the same way, Y is going to be equal to dereferencing B, okay? So if I just were to say here that I want to say that X equals Y, okay? But X and Y have no value here, so I can replace X with what we do have, which is dereferencing pointer A is equal to dereferencing pointer B. Okay, that's fine. And then I could also do this, right? Life would be good, or would it? Okay. So let's say we can kind of make notes here while we're going along. If we say that for funsies, let's say X is equal to 5 and Y is equal to 6. Okay. So when this is done, we're setting the star A, which is X, being equal to the star B, which is Y, which is equal to 5. Okay. So at this point, X and Y are both 5. So this is saying take star B, which is Y, is equal to star A, which is X, which is we said is equal to 5. If we just do this, both values will be equal to 5, which is not correct. Okay. So in this case, we're going to need a temp to hold things. The temp can just be an integer. We can say int temp is equal to the value of X, which is star A. Okay. We can then say A equals B, and X will become, no, A equals B. X should have been 6 in that other example. That would have been 6 as well. Oh, I killed something. Yeah, got the wrong end of it there. So if we say A, which points to the X back in main, is equal to what Y was. Okay. Y was 6 in our example we just did. So now X is equal to 6. Okay. Temp is equal to, so let's put this here too. Temp is equal to 5. Okay. So B then should be equal to temp. Okay. And that should set this equal to 5. Okay. So does this really work? Let's try it. See if I've made a mistake somewhere. The G++ dash O dash swap.exe swap.cpp. Okay. Doesn't like something on line 13. Let's take a look. There's line 13. You can see that it's line 13 at the bottom here. 13. Okay. I'm saying, oh, I left out an equal sign. That's why the rest of it doesn't work. Okay. So integer called temp is equal to that. See if that fixed it. Yep, it fixed it. I do a swap.exe and do 5 and 6, it swaps them correctly. Okay. So we're done. That part's good. Okay. If you have questions on that, make sure you let me know. Let's take a look at the second one, the positive negative. It's a little more complicated. Okay. So I'm just going to type that one in. And this should be, again, what was from the book. So in order to do this, or not from the book, from Canvas, we have to see what we're doing here. So we're asking for n, how many numbers are there? Okay. We're letting the user do that. Okay. We're then creating an array. Okay. This is a dynamic array. It's dynamic because we didn't know in advance how many we're going to need. Okay. We're going to say if they've entered 10, then we can say, okay, create a new array called data. Okay. The star gives us the memory address, so it's an array, is equal to new, that new keyword, int, n. Okay. And we know somewhere for the cleanup, we're going to have to get rid of this data. And that's where we're getting rid of it down there. Okay. So the next thing we're going to do once we've got that, we're going to ask the user for which values to put into data. Okay. So we're asking them to enter whatever we said, 10 integers, whatever. It's going to go through from 0 up to 10, increasing by 1 every time, and allow you to enter those numbers. This doesn't give a prompt, which is not perfect. And I tend to like to do things this way. This just gives a blank prompt, but you get the idea. Okay. Once we've done that, let's see what they're doing down here. They're next creating another array called positives and one called negatives. Okay. Both of these are being set to null pointer, which is the same thing as null. Either one's the same thing. Okay. So that means that we have created this pointer, but it doesn't point to anything. Okay. We're going to have to we have to allocate its value in our function, which is a little strange, but we can deal with that. And then we're going to set the positive count, the negative count equal to 0. Okay. We're setting those here in this function because down here, after we split the array, we're going to print out based on these numbers. Okay. The positive count and the negative count are needed here. Okay. When we call the function, we're going to send along the data. We're going to send along the size, which is n, the positives array with the positive count, the negatives array with the negative count. Okay. So that's what our function is going to look like. Again, we're not returning anything directly. We're returning it via memory, okay, by passing by reference. So the data we're going to call array, ARR. Since it's an array, we have to do an int star. It's a pointer. Arrays are pointers. The next one is the size. That's an integer size. Okay. These two, the positives and the negatives, are interesting. This threw me off a little bit in class. It's something we don't see very often. We would normally just do the int star positives and int star negatives, just like we did for the array. Okay. But notice that the array changed from data to array. Okay. So we're passing it by value, but it's a memory value. Since we want to maintain this name, we need to pass the array by reference because we haven't allocated the memory yet. Okay. So when you want to allocate the memory inside of a function, you have to do that star ampersand. It's the only time that you do that. Okay. So this is saying that I want this to be an array, int star, but I want to return it, or I want it to have the real address so it's visible back in main. Okay. And then this positive count, just an integer, but we're passing it by reference so we don't have to return anything. Okay. For both of these. And again, when you return two things, it's easier just to pass by reference, pass by reference, rather than trying to set up some data structure to send back. Okay. So that's what this means. So now we're going to go through, first thing we have to do here is to count how many positives and how many negatives. Now in class, a couple of you ask, is 0 positive or negative? Well, it turns out it's neither, and that's okay. You could, if you decided that it was positive, which I think I said in class the first time, then that's fine. You can count it as positive. You can also just count it as neither, in which case not all the numbers in our original array are going to get placed, and that's fine too. The stretch version of this program asks you to deal with the zeros separately with their own array. So I'm going to, for this one, just assume that 0 is neither positive nor negative. Okay. So I'm just going to have to go through this array. It's pretty basic, right? So I'm going to do a for int I equals, that's the wrong key, equals 0. Okay. Semicolon. As long as I is less than the size of my array. Plus plus, we're going to go through array item by item. Okay, I like to go ahead and put both of those in. Okay. And then I'm basically going to check here. I'm looking to see if the ith position of the array, is it greater than 0? Okay. If you're going to count 0 as positive, you would say greater than or equal to 0. But I'm just going to say if it's greater than 0. Okay. If that's true, then I need my positive count to go up by 1. So I can do a positive count plus plus. Notice there, my cursor didn't come back where I expected because I forgot to put in semicolon. If you hit a tab on a line, it will go ahead and format it again. Okay. So that looks okay, right? But I've also got here an else if the array sub I is less than 0. Okay. In that case, it's a negative number. So I've got my neg count plus plus. Okay. That should take care of that. When I'm done with that, I should have a positive count and a negative count. And because I'm not counting 0 as either positive nor negative, then it means that positive count plus negative count will not necessarily equal size. But that's okay. Okay. So we've got that part done. The next thing they ask us to do is to allocate the new arrays. Okay. So we're going to have to make a positive, and the arrays here we want are the positives and the negative. Okay. So we'll start with positives. So positives is going to be equal to new, I'm allocating memory. Okay. Int is the type that it is. The size is positive count. Okay. That's all we're doing. And again, I've got the new here. I better be deleting it somewhere. And notice this is visible back in main because of the way we passed it in by reference. And their positives and negatives are being deleted there. So we're not having a memory leak in our program. Okay. So in a very similar fashion, I can go through and say negatives equal new int neg count. Okay. So at runtime, these dynamic arrays will be sized to whatever they need to be. Okay. However big they need to be. Okay. Now we need to fill those with the correct values. Okay. So to do this, we're going to have to keep track of two things. We're going to need a p index to keep track of the positive integer positions as we fill them up. Okay. And we're going to need an n index for the negative values. Okay. Once we've got them, we're going to have to go through the array again and split things up, whether they're positive or negative, which means we basically have the same thing to do again. So if I go up here to the beginning, we don't cut and paste any max, we kill and yank. So Control K, keep hitting Control K repeatedly. You can hear my clicky keyboard. Keep hitting it till now, and then a Control Y to yank that back. I can then go down to the position I need it to be in here and do a Control Y again. So I've cut and pasted basically, or killed and yanked it. Okay. So this part's still going to be the same. We're still going through this. We still have to check for this, but we're going to be doing something different here. The first thing we're going to be doing here, we're going to, if it's positive, we're going to say positives at position. Okay, and here's where we need this key index is equal to the array at the current position I. Okay, but now it's the p index that we need to increase by 1. Okay, if not, if this is the case, that stays the same. We're going to go to negatives at the n index is also going to be equal to the array at the current ith position. Okay. And again, it's now the n index that's being incremented. Okay. And that should do it. We've done the 3 to-dos that we have. So we've determined how many positive numbers and how many negatives. Again, we're just ignoring zeros entirely. We're setting up new arrays, new dynamic arrays that we've passed in by reference, so they'll have value back in main. Okay. And for this one, we're doing a new delegate the memory, the size positive, negative counts. Okay. We're then setting up two variables, p index and n index, set to 0, which will track as we're placing values into those two arrays. Okay. And then we're going through the same loop that as we did before through our array using I as our index. And if the current position is greater than 0, we add it to the positives and increase the index. If not, we add it to the negatives and increase the index there as well. Okay. And if we're lucky and we typed it all correctly, that should work. Okay, so again, I can do my G++ dash O positive negative dot exe positive negative dot cpp. Okay, didn't like something. Okay, 2627. Take a look. See what I've done. Oh, what I've done is not made these ends. Okay, that was 26. That's 27. Again, I can look at the bottom here. See that? Okay. Compile it again. Okay. Do a dot slash positive negative dot exe. Okay. How many numbers? Let's say I want 10. And let's say I want 1, 2, 3, 4, 0. I want -1, -2, -3, -4, and -5. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be 10. Okay. Okay. So, interestingly, oh, okay, I see. It's that's the printout from the code is ugly. The positive number, the ones that we sent it are 1, 2, 3, and 4, which is correct. The negative numbers are -2, -3, -4, -5, and that's correct. The printout there is ugly. Okay, so I don't like that printout. Let's change that printout a little bit. Okay. The problem is going to be down here where we're printing them. Okay. Let's see. So it's going to say positive numbers, and it starts right there. Yeah, don't like that. So what I'm going to do, I'm going to go ahead and put a slash n there and a slash n there to put those in a new line. So it'll be a little easier to read. Okay, let's see if that works. Pilot, run it. And this time I'm just going to say 6. I'm going to say 1, 2, 3, -7, -8, -9. Okay. Yeah, I think that looks a lot better. Okay. While we're at it, what I would also do, just because I like things to look nice, okay. Again, when you have the time, it's worth doing. Going down to here again. Okay. I'm going to go ahead and put a new line character before each one as well. I think that'll help. Okay. I'm also going to add in a tab character. \T is a tab before the numbers. I do the same thing down here. And line up. So again, I'm going down hitting tab again to line things up. It's where I typed it differently than they did. Okay. And then again, at the end, we have to make sure, what if we created with the new keyword? We have the new for data here. We have the new for positives and negatives right here. And then the very last thing we're doing is clearing those out. Okay. So we can be fairly confident that we're not creating any memory leaks. Okay. Get out of there with Control X, Control C. Going to go ahead and compile it again. Still okay. I'm going to go ahead and run the program. I'll do 6 again. Let's do 1, 2, 3. Then do -7, -8, -9. Okay. And now you see that it puts some space around them. It tabs them over to the middle. Looks much nicer. Okay. So that's the second program. Again, that whole idea up here with this star ampersand is a little unusual. Okay. And again, we're probably not likely to see that anymore. But what they're saying is we're sending along a pointer by reference, basically. Okay. That hasn't been allocated memory yet. Okay. If it had been allocated memory, it'd be fine. It could share it, but it's not allocated until the function. That's why we have to deal with that. Okay. So hopefully that made sense. Okay. So you can watch this as many times as you want. I'm releasing this the same day. It's now Friday afternoon. So the homework's not due really, even though it was an in-class for the first 2 weeks, so through next week. We're just trying to get our feet wet and do a review of the code we've done last semester, hopefully. So you can just get it turned in by Monday and you're fine. If yours is not working, take a look at this video. I wouldn't cut and paste. I wouldn't exactly copy mine, but watch the video while you're fixing yours. I think it's the best way to go. Okay. And again, there are many ways to do this program. This is only one way. You will find the longer you program, the shorter your programs tend to get. That's not always true. Okay. So if you have any questions, make sure you let me know. You can text me or on my cell phone or email, or we'll talk about it in class. Okay.